Good afternoon, everyone, and welcome to the Lunch and Learn hosted by Wavelogix. My name is Suzanne Florick, and I'll be your moderator today. We're thrilled to have you join us for this insightful session on boosting ROI on bridge projects. Before we dive in, I'll review a few housekeeping items to give you the best experience. This webinar is being recorded, and a copy of the recording and any presentation materials will be shared with you via email afterwards. For the best viewing experience, we recommend using the gallery view. You can switch between views in the upper right-hand corner of your Zoom window. Please use the Q&A feature at the bottom of your screen to submit any questions you have during the session. We'll address them at the end of the webinar. If you encounter any technical issues, let us know in the chat and we'll have our support team assist you. Feel free to engage with us, use the chat function or the Q&A and share your thoughts, but please ensure your messages are sent to everyone for all participants to see. Now it's my pleasure to introduce you to Wavelogix and our distinguished speakers for today. Wavelogix was founded in 2021 in a partnership with INDOT and Purdue University to improve road and bridge reliability while reducing traffic disruptions. The Rebel Concrete Strength Sensing System provides real-time, in-place measurements of concrete properties, offering a more precise and versatile solution than traditional sensors. With patented technology, Wavelogix eliminates the need for preset maturity curves, delivering accurate results across various projects and helping teams optimize schedules and reduce costs. Joe Turek is president and COO at Wavelogix. Joe received a bachelor's degree in electrical engineering from University of Notre Dame and an MBA from Northwestern's Kellogg School of Management. He's been involved in manufacturing his entire career. He holds 5 patents involving high-performance microwave telecommunications circuit board technologies, and he is a registered professional engineer and member of the IPC and IEEE. Dan McCoy is a licensed professional engineer and civil engineer degree from Trine University and 27 years of experience in construction and concrete innovation. A third-generation bridge builder and passionate advocate for smart infrastructure, he's worked closely with the Indiana Department of Transportation and leading universities to explore cutting-edge materials and technologies. His recent focus is on enhancing concrete performance and longevity using nanosilica solutions like E5 and liquid fly ash. When he's not advancing infrastructure, he enjoys his family time, his wife, and his 3 energetic sons. So please join me in welcoming our speakers. And with that, let's get started. Joe and Dan, the floor is yours.
Great, Suzanne, thanks so much. If you have been following our webinar series, last quarter we did a set of 6 instructional webinars that talked about the technology. This quarter, we have the treat of actually doing kind of fireside chats with industry leaders, and we are excited about kicking this webinar off with our most favorite person in the whole world, Dan McCoy, the real McCoy from R.L. McCoy. Dan, thanks for joining us today. You're always entertaining. You will probably be the only one that we talk to that will be smoking a cigar through through our webinar. That's great. But that, as we know, anyone who knows you, is your signature. Some great cigars that you smoke. And tell us a little bit about R.L. McCoy. Bring us up to speed as to what you're doing there and what you're all about.
Well, thanks, Joe and Suzanne, for having me. This is definitely a fun time. And just so you know, the whole reason I smoke the cigars is much like modern coal combustion, I receive carbon credits for recycling the ash into concrete as a pozzolanic material. So I save everything and then offset that carbon. So those are available for purchase on my personal website if you would like those. All funds will be regenerated back into cigar purchases for additional offsets.
$1 million credit, right?
So yeah, right. So let's get into, everybody wants to know about R.L. McCoy. And I love saying that R.L. McCoy is has developed into what I consider, I have a strong link in military history that I love. And one of the things that I love specifically about R.L. McCoy is our size allows us to be what I consider the special forces of bridge building. So everything we are allowed to experiment on and do can be controlled in the crucible that we have in the area that we're in, with as much control over experimental process as we can muster. So it was started in 1960 by my grandfather, and that's where the R.L. McCoy comes from. That's Robert L. McCoy. And he was a World War II vet, came back and decided that after the World War, like most veterans, that it was going to be more beneficial to build things with his hands. He saw a need for that, along with President Eisenhower in the interstate highway system, and picked up a trade being carpentry, and then picked up another trade with building bridges. So it didn't take him too long to become pretty much a master at his trade and what he did. And my father decided that he wanted to be just like his dad, and build bridges. And he's continued that on. And begrudgingly, in his eyes, R.L. McCoy has grown quite a bit, because he's not so much pro growth, he's pro meaning. And I am the same way. No matter what you do, I hope you have meaning with what you do. So everything we're doing with Wavelogix, or anything we've done in the past with nanosilicals or polyureas, or all the new stuff that we're trying to incorporate and test to get into infrastructure to make it better, it has meaning. It has a true meaning for what we do. And then, of course, I wanted to be like my dad and grandfather and build bridges. So I figured the best way to do that would be to become an engineer, because neither one of them were trained in engineering. I think Grandpa went for a year, maybe a year and a half, and then he said, "Geez, I got to get out of here and make money.
No kidding.
I got a family to support."
Oh,
So then I was the first one to go to college, and earn a degree in engineering, and then obviously obtain professional licensure, which I absolutely love. I love the engineering is the interesting part for me. That's the side hobby. Building bridges, that's the main focus. But the other focuses that I find passionate that I'm for is the engineering behind what we do, how to make things better. Look at what every engineer does,
you're
Joey.
the
I mean, look,
technology pusher.
yeah, you want to find a better way. There's a better mousetrap out there somewhere. Let's find it. And if somebody has a better mousetrap than me, absolutely fantastic. I'm ready to learn. That's what's fun. That's what's absolutely fun. And then the other thing that we do, that we're probably more well known for across the state, the region, and the country, is our concrete pumping. We have a fairly large fleet of concrete pumps. We have the industry experts in concrete pumping. We're so fortunate to have them. And even though bridge building is where I'm from and my passion, concrete pumping is what I consider one of the coolest things that we get to do and get to work with customers and help them out. And that's really where a lot of my mixed design experience comes from, is solving those problems.
Sure, because you have to get it to pump through those pumps.
Yeah,
But
right.
mixing it right, it doesn't pump.
And this is definitely one of the things that got me involved with the new technology, is I saw in about 2020, 2021, you saw a really big push in the cement industry and then in the construction industry overall, to try and mitigate CO2, or at least manage it, because it supplied a bulk of CO2 in the industry. Now, mind you, cement is the second most widely used material in the entire world, water being the first. But regardless, the generation of cement produces CO2 as a byproduct. So it became a focus of legislators to try and reduce CO2. What that meant for me was, you're going to have people dictating, that aren't engineers, that are dictating standards that might be detrimental to construction,
Mm.
constructability,
That makes
concrete pumping, because as you optimize these concrete mixes, you're reducing the amount of paste, which is the direct correlation of the reduction in CO2.
right.
And that makes it a lot harder to do the things that we do.
Mhm.
And so I pretty much put my hands up and I said, well, if they want to find better ways, I guess I'll find better ways.
Yeah.
And I think we've done that, and that's what this discussion is truly
Right.
about. So
Yeah.
we're
So
looking at
if
life
you don't
cycle
mind,
analysis. Yeah.
yeah, let's build on that technology and that, the concept of being a tech leader. I mean, so you've been around since the dawn of time with bridge building. You're you and your family and that, which is great. So you've seen technological innovations occur as they come online. Of
When I
course,
saw Julius Caesar with the first pile driver, horse-driven pile driver for timber piles, uh,
boom, right? It's crazy, right? So from Roman times, there you are, you're building bridges just like the Romans did. But using a lot better technology. Certainly, the Rebel sensor is, we consider it an IoT device, an Internet of Things, a sensor that connects up to the cloud and is collecting data and sending it off that allows us to do things in the infrastructure that you couldn't do before. Are there other technologies and changes that you've seen that are using IoT type devices? How is the technology, you know, come about? I mean, we're seeing like graders and things that use GPS, centering in that. How in the bridge building world or in the pumping world are you seeing new things, integrated in?
well, that's just it in the construction industry and in civil engineering in general. Um, there is a theory, and it's a very good theory, because we deal with, especially in transportation and especially in large buildings, vertical
Mhm.
buildings.
Yeah.
There is a long-standing tradition of making things not break.
Hmm.
There is a public interest in saving lives and keeping people alive.
Hmm.
So new technology in these sectors is usually shied away from because the old science, and I mean it's old science, but it's factual science, it's physics. But the term, we don't want to try anything new because what we've been doing is working so far.
Hmm.
There's a lot of built-in redundancy in what we do in engineering for civil structures. Now,
Hmm.
as you know, Joe, in the electronic world, in the computer science world, in the automobile world, or even in other mechanical trades, there's always advancement, because the next generation is just 2 months away or a month away.
Right.
Um,
Right.
so it's always advancing. In civil engineering, when we build something, we're talking about, especially, let's just look at bridges, since everybody wants to look at bridges today. You're dealing with a life cycle of minimum of 75 years for any
Wow.
structure.
Wow.
So, so the the choices you make today are going to impact what's happening in 75 years, which is roughly
Yeah.
two,
Yeah.
two generations away, roughly.
Right.
Okay.
Right.
Um, Now, I believe that some bridge structures, uh, depending on their design and their construction, and that's type, not so much whether it's poor design or not, but type of structure, you're definitely going to see structures last 100, 120 years.
Hmm.
Um, so people are very skeptical to put new technology in things where they have a proven track record and they don't want to mess with it. They don't want to be the one to reach out there in experimentation and say, well, let's try this.
Yeah.
It in civil and structural engineering, it doesn't really happen all that often because of the huge consequences and
Hmm.
liabilities that you find in that. So when you ask that, it takes an awful lot of time for anything, any product, or
Hmm.
any advancement, to go from a proposal
Hmm.
into an approval, both at the federal highway level and at the
Hmm.
state level.
Yeah.
And I think you'll know that mostly in as the interstate system goes, the federal highway department is very partial to bridges and
Hmm.
bridge inspection, and rightly so.
Yep.
So in almost every bridge in the United States, the federal highway has a little bit of their hand in. because they mandate, such things as inspections, biannual inspections, and
Yeah.
critical analysis of lower tiered or structurally deficient structures. So that's why in bridges, pushing new technology is so important, because I've always said, in even to you, Joe, for this product or the other products that we work with, we are at the pinnacle of research and importance in what we do in concrete technology.
Yeah.
But
Yeah.
we do not control, not even in the least bit, the
Mhm.
actual volume of the concrete placed.
Mhm.
However, the people that do place large volumes look
Mhm.
to us in the transportation industry for verification of new technologies and materials.
Yeah.
And that's why it's so important. We are the proving grounds, usually, for most other professions in civil engineering.
Right.
Uh, if
It's
a private
interesting.
entity or a commercial developer is going to use something, um, rather than write their own specs or try
Right.
new materials, they'll reference the specifications for materials out of Federal Highway, AASHTO, or
Yeah.
their local Department of Transportation.
Yeah, I'm glad you brought up like AASHTO. Now we have an AASHTO spec T412 that regulates the use of our sensor technology in concrete curing. But like you said, it's when we talk to the DOTs, their first question is, well, who's using it? What are the contractors saying, right? Because they look to the contractor community to be the proving grounds, as you said, of any new technology. You're the first line of defense. If you don't think it works, then it's not going anywhere, regardless of what you write in a spec. And no governing agency wants to put into a spec a product that isn't going to be useful or is going to be detrimental to the safety and durability of the structure that's being built, right?
Well,
If I
you would
look,
think so, but with Type 1L cements, maybe they didn't listen.
yeah, maybe they did. I mean, yes, we all learn from mistakes. We're not going to go there.
We're not going to go there, right?
That's a whole nother webinar when we start talking
We don't
about
want to
products.
upset the oligarchy gods of cement.
Exactly, exactly. So if we go full circle with this, you've had a chance to use and try out our sensors. How do you feel about our sensor technology? Is it advancing bridge construction, and how do you see it kind of fitting into the infrastructure?
Well, the short answer is absolutely yes, and it will continue to impact bridge construction. Um, and there are, for those of you on, I think maybe you do or maybe you don't, or you're interested in this type of technology, and you say, well, it's a bridge sensor or what's a concrete sensor? And
Mhm.
there's several different methods out there. The competing, it's not really competing, it's a totally different method, but maturity testing.
Mhm.
And all that is a correlation uh, between the Fahrenheit hours or the Celsius hours, and what you did with a sample set of the same mixture compared
Mhm.
to what the temperature you get in hydration from a mass pour.
Yeah.
It's merely drawing a correlation between the two. There's no live monitoring.
Mhm.
You get a live monitor of temperature, and then it's plugged into an equation to where you get. There are some issues with that. If you mess up or don't follow the procedure for the control
Mhm.
testing right, that could be a mistake. Um, and if you don't, maybe go the extra mile on some real critical stuff, go the extra mile and find the actual activation temperature. If you're going to be
Mhm.
placing concrete in somewhat marginal conditions, maybe exterior temperature is below 32. Where's that activation temperature at? That is a whole nother ball of wax to get into with maturity testing that usually is taken for granted. They just say, well, if it's above 32, it's okay. And there's a couple papers that say that's fine. And for generally the most part, I'll buy that. Um, Now, of course, there's some new untried methods out there, that I believe that other people are taking a look at, involving resistivity.
Mhm.
It's a whole thing. But what I really like about and that's been looked at before. But what I really like about Wavelogix and the Rebel sensor is, number one, Luna Lou. I mean, obviously, I heard I
Who
heard
doesn't
her.
like her?
Who doesn't like Luna? I mean, Luna's my girl. She's my girl. But if I heard her speak. I think it was an IC squared conference, and it was during COVID. So naturally, I could be I could be as loud as I wanted from the comfort of my own home, screaming at the screen while I'm watching the webinar. But what about this? But what about this? I got so excited. And I'm asking all these questions. And of course, my list of questions in the webinar was about that long. And Luna and her cute little voice, she goes, "Who is this Dan McCoy?" And I went, "Just a dummy that wants to learn more. That's it." And that's how we got hooked up to try these things, and how exciting it is. So yes, as it goes, but we have to look at where the old way was. There were so many inconsistencies even today, because you're talking about we're not inside a building, we're not on a bridge site. We're either in a crest vertical curve on top of a hill, or we're in a sag vertical curve crossing a ravine. So the location of where we do our work is really kind of hard to do for in situ tests that involve making concrete cylinders or beams, and then being able to treat them right as if they were in a laboratory environment, so that we can get proper data from those destructive tests. And notice I said destructive tests.
Right.
The one thing that I don't like about they've been around forever. It's a foolproof method. You put a cylinder in, you squash it down, you get compressive strength. That's what we design off of engineering. You take that 0.85 F prime C, and away you go with designing. But when you break that cylinder, the only thing that it tells you is that at that very moment, what the compression strength of the concrete is at that very moment. And it's only for that concrete cylinder. It doesn't say anything about the other cylinders, and it doesn't say anything about the cylinders that you broke 2 days ago, or the cylinders that you're going to break in another 5 days.
Yeah.
So in one instance, a snapshot of time. And I think that's one of the things, and I'll equate this to anything else in history. There's a big difference between watching a video of something happening and a single snapshot of an event. And with destructive testing, all you have is that snapshot of an event.
Yeah.
So the benefit we get from live actual monitoring is you don't have the human hands. I mean, as much as I love to touch stuff, I know every time I touch something, as Schrodinger says, I've screwed up the results. So that's a double E joke for the double E in the room. But
thank you.
as soon as you've touched it and observed it, you've essentially changed the results. And what I'm saying is, the more human hands that touch these specimens or make these specimens, it varies in that line. Now, ACI and an ACI technician is a wonderful thing to try and make it constant for what you do.
Yeah.
You still have mistakes being made. And one of the questions we always have, if we do have a low break here, or we do here, it goes back to, well, how did you make the cylinders? Did you move the cylinders at less than 24 hours? Did you cover the cylinders up? I mean, were they actually heated, or did it freeze overnight? And then when you did move them, did you put them in a tank, or there's all these questions to verify, but
that could change
technology of the Rebel sensor gives a foolproof way. And that's what I really like, is the consistency that you get. And obviously, as more and more uses build up, what's nice is the AI technology will begin to come together to where most of the data that Wavelogix is going to have will be able to assist contractors and be able to assist ready mix suppliers in optimizing their concrete mix design for maximum savings. And that's what's really cool. It's a cost saving measure for anybody that's using it. I see that in very large, in very large vertical applications in bridge building, for example, when we move piers. So we'll do a pier, and then we've got a schedule to keep when it comes to placing that pier stem. And we have minimum strengths that we need to get before we can remove those formworks and move it right up the line in a jacking system type variation. So that can save, usually it saves, in the worst case, saves several hours, because you don't have to wait for a break. In the best case, it saves several days, because you don't have to wait for a break. You get a bad break, and then you have to prove to someone that this concrete's not bad.
Yeah, right. That's the hard part.
So that's where it really affects scheduling.
Yeah.
Right. And that's what I tell people in concrete pumping. Would you rather me place at 100 yards an hour, or would you rather place a bucket at 2 yards every swing, which ends up being about 12 yards an hour?
Mm-hmm.
So the time is money equation comes across fairly quick with the Rebel sensor, and that's where I see the benefit
Yeah.
from a contractor's perspective.
Mm-hmm.
That and and I think INDOT will be coming out with its own memo shortly about using the sensors, and they're very cautious. And I love the way INDOT does stuff, because they do use a belt and suspenders method. They use an experimental method. They don't go with the technology and say run with it. There's a verification process, and I love the fact that you verify too. You do the work,
Yeah.
and then you verify it, and then you prove it, so that there's not a shadow of a doubt that when we're ready to go and only implement the Rebel sensor,
Mm-hmm.
it has been vetted and tested and approved
Yeah.
by none other than a very respected DOT.
Mm-hmm.
And so I think as you said, where do we go in the future, and what does it have in the future? I like that not a lot of human hands have to touch it.
Mm-hmm.
And I like the fact that the technology works standalone, regardless, and compared to maturity testing, regardless of what data you've taken from another sample set that you have to input to get the data that you need.
Right, right. That's a great summary. So if I can, let me summarize what I've heard you say very eloquently. You don't like cylinder breaks. They have inherent variability. They're not timely. They couldn't give you errors in it. And what you like about the Rebel sensor is that it's real time, it's in place, and so you're getting more accurate measurement of data. And it's reliable. You can do your next operations and be more efficient at that, because when you know a real-time data, you can start to remove forms or do the next operation. And so there are efficiencies that way as well. So along with accuracy, improving efficiency, which all translates to lowering the cost and giving you what you need. So yeah, I think that was nicely said, and we appreciate that type of feedback for sure. As an update with INDOT, which is they brought us to the table, and Luna had developed this technology based on their desire to get something better than what was out there already. They've done vetting of the product in their own labs over last year, and now they're releasing special projects this year. There's a bid out that's going to be a paving project, which is quite extensive. It'll be about a 6-month project that we'll test it. They're also looking at maybe some special projects with bridges and doing more of those. So this year with INDOT is going to be spent actually working now with the contractors in real life projects, comparing it. And then our hope and desire is that by the end of the year, they'll have enough data that will allow them to write our product into their spec. Massachusetts has already written our T412 specifications into their state specs, which is great. And we're working with multiple other states around the country. I think right now we have 10 actively looking to implement it into this year's specs, and about 35 overall that we've been talking to. So yeah, it's we're getting the ball rolling, and it's guys like you, Dan, and R.L. McCoy that are really helping push and validate the technology. So we really appreciate that, and keeping it up. So with that, I think we'll stop it there. And Suzanne, are there any questions from the field that people want to ask Dan?
There were a couple. One was, could you talk a little bit more about saving labor with the sensors on some of the projects?
Sure. So one of the things that Joe didn't bring up that I really liked about when people say they're waiting for a beam break or they're waiting for a break, you have an idea of when it's going to be. But when it comes to organizing labor, there's a big difference between mobilizing a crew and then actually performing the work.
Mhm.
So when you get a break, maybe it's at 1 o'clock in the afternoon because the engineer didn't get time to go pick it up out of the tank because he was doing other things. He breaks it. Then he waits a little bit, he's doing some other stuff, and he finally calls you at 2 o'clock. Oh, hey, by the way, we got a beam breaker or a cylinder break, so you can go ahead with the next phase of work. Meanwhile, you're probably doing something else, but you could have been preparing that entire time to move up with the project. Now, what I like about the AI behind Rebel is it's predictive technology that basically says, okay, here's where we're at now, and then this is probably where we're going to be at in here, and you can project that forward so that I can have my crew mobilized and ready, so there's no wasted time in the mobilization to get on task with the project. That's a huge savings. When you're talking about a crew, especially even more so in vertical applications, if you're talking about false work removal and then form placement in several levels ahead, and you can organize a crew 2 or 3 hours early, and we're talking about a 40 or 50 man crew. Add up, folks. People don't get paid $2.75 anymore. I mean,
Right.
with benefits and true labor, each one of those man hours is probably somewhere between $68 and $75 an hour by the time you're done with it for each one. Now figure out that per minute. It becomes a minute cost. Now, we're not talking about the GM assembly line being stopped for 10 minutes. I get that.
Right.
But for a small business or even a medium-sized business, and maybe it's one of these concrete contractors that does $500 to $700 million a year, their payroll costs are very significant in terms of minutes. And if you can save those minutes, and especially I'm sure you could save hours with knowing that predictive algorithm to say we're going to hit this strength there, all we do is look at our phone, verify it, we're ready to go. So we've already got things in place, right? And here's the other benefit. Say it's not ready to go when you're ready. All you have to do is wait a couple minutes. You don't have to wait. You don't have to wait for the engineer to call back and say, "Hey, we didn't break. We're just 25 psi away. I just can't let that fly. So we'll break another set tomorrow. Tomorrow? You're going to break another set tomorrow? We're 25 psi away. Whoa! I've only got 6 cylinders left. Do you want me to break them all now, or do you want me to wait until we get a passing 28-day psi? You see how it becomes a sliding, slippery slope. And what I do as a manager. Do I waste these cylinders and tell the boss, hey, we never made our 28-day strength because I had to burn the cylinders up to prove strength to be able to tear forms out?
Right.
That's a very simple example of how you can save labor in just one scenario.
Yeah, that's great.
Excellent. I've got one more. I've got some people that are a little bit interested on ready mix and how the sensors work in your mind with ready mix and what the benefit is.
So, as I've talked about before, as far as being able to supply the Rebel sensor, I think in my little mind that one of the best things that a ready mix supplier could do is probably carry these in stock. Because you may have some smaller commercial clients, or maybe you have a special application of a residential client that they really need break data and they really need it fast, or whatever the scenario would be. Now, on a DOT scenario, I've always got a ready mix QC guy there because it means that much to them, because NDOT won't pay if it doesn't meet all,
Right.
So I'm kind of the baby. I get pampered a lot. But on other ready mix jobs where they're just suppliers, the QC becomes a cost to them when they're supplying those yards of concrete. So if you can actively place a sensor, and even a sensor that maybe doesn't take a lot of training to be able to place, and you don't have to form a maturity curve to be able to get, say it's an off-brand mix that hasn't been through standard deviation or all your testing with maturity for 28-day strength. Maybe it's a custom mix that they want to find out right away on. You can send the sensor out and tell them, hey, put that in the pour about a half hour before you guys start. You could even send it out with the first ready mix truck, and you could actually place the sensor about 25 or 30 feet back from the pour where it's going to be. So by the time the 4th trucks get there, that's when it'll come over. So there's your placement. And then a QC guy can actually go out and actually plug in the cable and put on the data logger, or you could send it out and have it done. But then it's already in place, and you don't have to have that QC guy that maybe has 3 other DOT projects that he has to be on that day. He doesn't have to go to that pour, make a whole set of cylinders to be able to test the next day for that individual. So it's a real cost savings, I think, for in terms of quality control. But it could also be, if they put a little, because it's America, let's make money. If they put a little markup on the customer knowing that knowledge, then they could sell the sensor with a little bit of a profit margin to them. But then they also get to retain that data. That's cool. So now whatever mix that they have, they retain the data for that mix. And then they make another mix and another mix and another mix. And even though they've sold that to the client, they're going to report back to what they're getting on that mix to the client and say it's okay.
Yeah,
But they get to retain that data, and they get to know more and more and more and more about the mixes that they're using and the efficiencies that they're getting between their cement and their brake strength combination to optimize their mixes to be able to sell more cement or less cement in more yardage, if that makes sense.
Yeah.
That's great. That's great. Good input.
Very cool.
So I've got one last question for you. And what was your first bridge project that you worked on?
I don't know who you got this from. The very first bridge project that I worked on. I don't know if I worked.
Or that you were part, yeah. But since you're up in the industry, what
this
was
is tough. This is incredibly tough. I don't remember it, but there's pictures of me being on the State Street Bridge. It was doing an overlay in late 1982. So I was about 6 months old, and I was out with my dad. My mom had brought me out, but I was out with my dad on that bridge deck to see Grandpa, evidently, because it was close. And they took pictures, and then I remember later on, I'd start working in the shop. For all of you Department of Labor people that are listening, I didn't start working in the shop. I went to the shop on my own free will, at around the age of 10 or 11. And hung out with the guys in the shop, so that you begin to be a yard dog. So you see all of the ingredients coming together that then ship out in one unit to do the work, and you see it in phases of which and where each bridge project is at, and then you go out and help and put it together. But yeah, that's a hard one to answer, Susan. I can't tell you which is my first bridge. I've never thought about it.
Just thought I'd throw that one at you in closing.
I've actually never thought about it, but I will tell you, since when I 2 years old, State Street, I do remember them, or excuse me, 6 months old at State Street in 1982. That was the first one I was on.
So how about this? Is there going to be a fourth generation of R.L. McCoy boys?
Well, that's an interesting question because you don't know. I think, and Luna maybe could answer this better than I could, and I'm excited. She heads up the Center for Intelligent Infrastructure out of Purdue, and they are doing some monumental things. You'd asked what other technology before, Joe, and it goes all infrastructure, not just highway or bridge, what we were talking about here, but everything from providing magnets and mag rails and roads to battery, to be able to transfer charges to mobile batteries, 5G communication, and being able to. So the question is, if a fourth generation comes along, what are they going to be doing? That's how fast our industry is changing.
Yeah.
So am I going to be, are they going to be building mag rails? Are they going to be building independent trucking corridors that are only meant for that? Are we going to build specific structures that are just for autonomous vehicle travel? That's what's cool, right?
Yeah,
so,
right.
Yes,
exactly.
I agree. In the simple span of what a bridge, yeah. But what cool stuff are we going to do in the next? It's already advanced more in 20 years than I could have imagined in my wildest dreams with material technology and AI. And I can only bet that the way AI is moving now, what we're going to see in another 5 years in the construction industry. So what a great question. My answer is yes, but will it be the stuff that I was doing, that my father was doing, that my grandfather was doing? I think it'll radically change the use and what we're doing.
Yeah, great legacy and great way of moving it forward.
Well, I told you guys, we're at 40 minutes. I told you with me talking, it was going to be real easy to fill this time.
And it sure was. What a joy it's been having you on and talking about your meaning in your work and all your visions. And we really appreciate your time and energy in this.
Yeah. Thank you, Dan.
Hey, no problem. I'm just here smoking cigars. If you guys got any questions, you can always hit me up on an email. No problem. My wife doesn't let me out of the house much, and I'm not allowed to talk concrete with her. So if you guys send me emails,
All right.
love answering questions.
That's perfect. Well, thanks again, Dan, and we really appreciated you being on our Lunch and Learn, and we look forward to talking to you soon.
Thank you. Thanks, Joe.
Thanks, everybody.
Thanks, Joe.
Bye.
Bye.